A classical complex four-wave foundation of the cosmic quantum mechanism indicates the development of a model of fundamental rest mass quanta as simple harmonic oscillations of the space-time continuum, driven by its expansion at resonant frequency and wave number. While a four-dimensional model of space-time, this differs from general relativity, in which the strain of space-time or curvature is modeled as a function of the stress-energy tensor of quanta. As developed here, the various strain-induced spin properties of quanta are a function of the stress-energy tensor of space-time under expansion. The inertial constant tau is modified using the Euler identity for the various fundamental mode orthogonal functions of space and time through the various powers of kappa and omega. Conceptually, mass is a measure of wave number, itself the inverse Compton wavelength over 2 pi, and a complex modulus. Tau then is the invariant product of half-spin quantum rest mass and radius equal to h bar over the speed of light. The economy of this approach will become apparent. Our motivation is the following phenomenology involving Compton, true for the neutron but for no other particle. Assuming Compton is a physical radius and not simply statistical, we apply Newton's equation to two neutrons with boundaries in contact and find their interaction equal to Compton squared divided by 6 times the square root of 3. From the units, this value appears a covariant derivative of central wave force with respect to stress, and will be found to constitute a gravitational quantum, with which we can state a quantum law of gravity, of which Newton's constant is an expression. The proof of this quantum formulation, substituting the following identities for mass and distance, giving us Newton's law. We want to analyze an isotropic expansion of spacetime, specifically to determine the contribution to a unit 3 and 4 cube strain made by an incremental change in each orthogonal boundary component. Shown by strain vectors S, E, and C, and for the 4 cube not shown, V. Note the differential change in surface area assigned to a length change along one diagonal, as stated for quantum gravity. We look to various ratios of the orthogonal component sums, all set to 1, as inflection points for the increase of the consequent over the antecedent, and solve for A. We look for complex solutions indicative of rotation and oscillation. A significant few, here circled in solid, the dash signifying equal-valued real solutions. With the 3 cube, we find a coupling with a modulus of square root of 3 over 2, representing a rotation of S through E towards C. For the 4 cube, we have one indicative of the maximum power of a wave, one of oscillation about a 3 cube diagonal, and a recapitulation of the 3 cube with larger modulus and an argument indicating rotation into the cubic diagonal. From such analysis, we create a model of a rotational oscillation or spinner. This model is an instance of simple harmonic motion in which the strain oscillates between the nodes of spin axis theta. For each point on the stress path theta, the strain forms a figure 8. The result is the creation of an orthogonal rotational axis phi, constituting a rotating magnetic dipole of chiral polarity rotating about theta, with the creation of an effective magnetic moment antiparallel to the spin. A point K on path theta, orthogonal to the nodes of theta and phi, oscillates between K, a point of maximum kinetic energy and current, and plus and minus V, the points of maximum potential energy and charge, going through a positive and a negative capacitive phase on the leading edge, and a positive and a negative inductive phase on the trailing edge. Each cycle takes the strain through two capacitive maximum power moments and two such inductive moments. Crossing the point of maximum kinetic energy into these moments in the direction of increasing force gives a capacitive and an inductive torque that are 90 degrees out of phase, rotating about theta. Right hand in the direction of increasing force, the inductive torque is left hand in the direction of time or motion. In the neutron, they are on opposite sides of path theta. In the presence of an external magnetic field, the inductive torque aligns with the field, and the spin and effective magnetic moment vectors precess. With expansion and a decrease in density and impedance, the magnetic dipole and quantum strain advances. The inductive torque flips behind the capacitive torque with emission of wave power, which is the electron. Cosmic expansion constitutes an inductive phase in which potential energy density is converted to kinetic energy. With antimatter, the strain is retarded. The capacitive torque flips down in front of the inductive torque, both antiparallel to the spin vector. And the positron is emitted. Thus, antimatter denotes a capacitive phase. Quark phenomenology is the ontology of the quantum spin nodes and antinodes, necessarily confined to the boundaries of the quantum strain. Mixed parallel and antiparallel interaction of the capacitive and inductive torques with the nodes and antinodes of hadrons modifies the dynamics of transverse momentum, producing fractional charge, parallel indicating positive and anti-parallel negative. In the case of the neutron, they cancel. In the case of the proton, the products are parallel for stress and charge, and anti-parallel for the dipole strain. For the antiproton, they are anti-parallel for stress and charge, and parallel for the dipole strain. There is a lack of leptonic internal structure, since for the electron all are antiparallel while for the positron all are parallel. Here is an orthonormal spin strain matrix of the oscillation. To understand the dynamics of this system, we look first at an ideal jump rope oscillation and find the following kinematic expressions at any point in its path. Followed by the dynamic counterparts expressed in terms of the inertial notation. Here it is depicted graphically. We also have the following space derivatives. We can complete this picture with a 4x4 orthogonal matrix of functions in which we find the following. With some elaboration, these characteristic functions form an orthogonal and highly symmetric matrix of covariant derivatives, an embodiment of Noether's theorem in which the rows of Euler's calculus gauge the time through the angular frequency and the columns gauge the space through the angular wave number. This gives new meaning to the following equations. Here we have the inertial constant as an invariant displacement strain potential and the four-dimensional expansion stress operating through the 3D tension components. Mass-energy equivalence of relativity. Action energy of quantum mechanics. Inertial constant spin energy of this model. Wave force inertial density. Impedance and power. Finally, and most importantly, we have the following gauge couplings for the electroweak interaction and for gravity, the latter corresponding with our initial motivating observation concerning the neutron and Newton's law. This slide states the unification of the two couplings. Also of interest is the inverse Planck area and its coupling via the gravitational derivative with the scale of the strong interaction. A graphic representation of the orthogonal matrix as a potential at left and with half pi rotation of all components at right. Here are the right-hand rule and the left-hand rule. An alternative description of the spin space using negative curvature, which we dub an inverse sphere. The geometric basis for electron-neutron mass ratio related to our analysis of expansion on the orthogonal boundaries, with its agreement with the codata values. The relation of the dynamics of beta decay where IE sub 2 is a differential shear invariant which normalizes a logarithmic differential tension change, giving the following differential ratio and the cosmic expansion rate, with the corresponding predicted Hubble rate. An exponential expansion rate gives the age of the cosmos in current terms as 288 billion years. This represents a doubling of 31 times. Analysis of the Planck scale using the Planck wave number shows the cosmic extent to be comparable. At 285 billion light years. This does not mean that space is expanding at the speed of light, rather that measures of distance and time are covariant. Space-time flux modeled as expansion from a fundamental scale at left or condensation from an invariant cosmic extent at right. Modeled as an ideal horn torus, which is of indeterminate genus, sharing the topology of sphere, torus, and Mobius surface. Conclusions. Space-time and quanta did not emerge from a Big Bang singularity. The universe is best modeled as a three-horn torus under expansion, or as quanta under condensation. Strings or loops are not responsible for quantum gravity. Density decrease drives spin, gravity, and beta decay. Speculations. The present cosmic cycle is of the order of 288 billion years. The natural log of 2 is the nature of dark energy. Active galactic nuclei are fonts of hydrogen plasma.